Okay, so you differentiating use the product and quotient rule. So the product rule is used when you have, y equals f of x, g of x. So a product of two functions, for example, we could have y equals x squared sine x, or we can have y equals, so the chain rule, you can't split it up, but with the product rule here, it's two separate functions multiplied by each other. You could have x squared minus 3 to the power of 4 times by e to the x. Okay, so you could put a wee multiplied in between there. So it's a product rule. So product rule is used for that, and then quotient rule is used when you have y equals a function of x divided by a function of x. So for example, you could have x squared over sine x, using the same examples, or you could have y equals x squared minus 3 all to the power of 4 divided by e to the x, whatever. So product and quotient rule, they're very similar. So rather than writing with f and g, we can write with y equals uv, okay, 2, and y equals u over v. Okay, so it's important in the quotient rule that the v is on the bottom here, v on denominator. Okay, so dy by dx is v du by dx plus u dv by dx. And for the quotient rule, it's v du by dx minus all over v squared. Okay, so those are the two rules that you need to use in your assignment, product and quotient rule. So for the product rule, it actually doesn't matter what way round you have these, but I always write it that way because the quotient rule, it does matter. So I write the product rule this way so that the quotient rule can be written the same way. So yeah, that one can be written, that one can't be written either way, but that one can. Okay, so let's do a couple of examples. Example 1, find dy by dx if y equals 6e to the 2t sine 4t. Okay, so we're doing dy by dt here rather than dy by dx. Okay, so this is the product rule. Okay, so u equals 6e to the 2t and v equals sine 4t. So we do the du by dt is 12e to the 2t, and dv by dt is 4 cosine 4t. So putting it together, dy by dt is v du by dt plus u dv by dt. So then you just, and if you write them the way I have, then it's kind of like cross multiplying. So it's 12e to the 2t sine 4t. Okay, it's just nicer to write the trig term at the end, plus then that's 24e to the 2t cosine 4t. Okay, so it's quite a long expression, but that's it. You could factorize out the 12 and the e to the 2t, but you're not really getting anywhere with that. Okay, so let's do example 2. Find dy by dt Okay, so we've got, got u equals 7e to the minus 2t, and we've got v equals cos of 2t. So the minus 2 comes down, so that's minus 14e to the minus 2t. And that's minus 2 sine 2t. So putting it all together, dy by dt, again, it's this by this and this by this. So I've got minus 14e to the minus 2t. Okay, and that is the answer. So that's 2 examples of the product rule. Let's try one of the quotient rule. Okay, so u equals 6e to the 2x, v equals x squared. So v has to be the denominator. It matters. So du by dx is 12e to the 2x, and dv by dx is 2x. So put it together, dy by dx. Okay, so this time it matters. So it's v du by dx, so it's 12e to the 2x, x squared, minus, actually it's nicer to write the x squared before the e to the 2x. 12x squared e to the 2x minus 12x e to the 2x, and then that's over x squared squared, which x squared squared is just x to the power 4. And you could cancel through by x if you wanted. So you could cancel, so that would be cubed, that would disappear, and that would become x. So so u is the top one, v is the bottom one. So put it together, dy by dx is 3x squared cos x minus 6x sine x over 3x squared squared. I'd be careful with that. The 3x squared squared becomes 9x to the 4. And then we can cancel. So 3 goes into that 3 times, goes into that twice, and then the x cancels. Okay, so fully simplified, we've got x cos x minus 2 sine x over 3x cubed. And that's it, fully simplified.